Welcome to Pravdan Tutorials. Please kindly subscribe. Thank you.
Welcome once again to Pravdan Tutorial. In this lesson, we will be looking at the application of quotient rule to differentiating a tan function, tangent. Okay, we're going to start with y equals tan x. At the end of this, we're going to have that the differentiation of a tangent function tan x will give you the seconds, shortened as sec, the secant squared x, or you will get 1 plus tan squared x. So how do we arrive at this? We are going to be applying what we call the quotient rule. So to start with, we have y equals tan x, which can be written according to trigonometry. Tan is the ratio of sine to cos. So I have sine x over cos x. Okay, and in this case, applying our quotient rule, this is in fraction form. U is the numerator, which is sine x, and the v is the denominator, which is cosine x. Remember, you need to differentiate these two. So we need the u, the x. When we differentiate sine, we've established in one of our videos that you will get cosine. So that is cosine x. And we need to differentiate v also with respect to s. When you differentiate cos, we'll get negative sine x. Having all this, then you need to recall what the quotient rule states. So if you remember, if you also check our video on quotient rule, if y is in fractional form uv, where both u and v are function of x, then it says that your dy dx is going to give you the denominator, which is v. Then you differentiate the numerator, the one on top, the u, the x, minus the numerator u, differentiate the denominator, dv, ds. All of these divided by the square of the denominator. This is quotient rule, and that is what we are going to apply now. So having recalled this, then we can come back to this now. So our differentiation of y with respect to s is going to leave us with v. What's our v now? We have the cos x, the u, the x, and that is also cos x, minus u, which is sine x, and we have our dv ds, this one, dv dx, which is negative sine x, all divided by v squared, and our v is cos x. V is cos x, then we have the squared on top, squared. Okay guys, so from here, what are we going to have? Cos x times cos x is written as cos squared x. This is negative here, times this negative is going to leave us with positive, and sine x times sine x will give you sine squared x, all divided by cos x all squared, which means multiplying cos x 2 times will also give you cos squared x. Okay. Trigonometry, we can also recall that this function cos squared x plus sine squared x is going to give you 1. It's a standard that has been proven in trigonometry. So if we know that dy dx will now be, the whole of this is 1 from trigonometry, 1 over cos squared x. Okay, and the inverse of a cosine function, the inverse of a cosine function is what gives a secant function. So this is sec squared x, which is our first proof. Successfully, we have this. Secondly, if you want to proceed from here, we can still write these as cos squared x over cos squared x plus sine squared x over cos squared x. Yes, we can still split it this way, and from this we see that the numerator here and the denominator are the same, so the fraction is going to give us 1 plus, remember we call that the ratio of sine to cos will give you tan. So sine squared x divided by cos squared x is going to leave you with tan squared x. So that means that your result of differentiating a tan function is giving you sec squared x, or the second one, 1 plus tan squared x. And that is it. In our next video, expect to see examples that relate to differentiating a tangent function. See you in our next video. Stay tuned. Bye bye.
Please kindly subscribe. Thank you.